Okay, let's turn next to measures of dispersion. And when it comes to measures of dispersion, there are essentially three. And the easiest is the range. The range is simply the maximum value minus the minimum value. And we have already encountered working with the range when we constructed a histogram. Then we needed to know what is the highest value, what is the lowest value in the data set, and then we divided by the number of classes. Then a very important measure of variation is the variance. And when you look closely at the variance, we calculate the sample variance differently than the population variance. When it comes to the mean, it doesn't matter whether we have the population or the sample, the formula is essentially the same. But now when it comes to the variance, they look different. But let's first talk about what the variance is. So in words, then I find it helpful, in words, the variance is equal to the average squared deviation of all observations from the mean. So the variance is the average squared deviation of all observations from the mean. And for the population variance, we typically write sigma squared. And then you see what we do. We take every observation, we subtract the mean and square it. Then we do that for the next observation, we subtract the mean and square it. And we do that for all observations. Or in some notations, we sum up all the squared deviations from the mean for each observation and then divide by n. But whenever we have a sample, we do essentially the same thing. We call it S squared, the sample variance. But we divide by n minus 1. So once we divide by n and once we divide by n minus 1. I will explain that later, why that is. For now, it is just important that you know that there is a slight difference. So the variance, again, is the average squared deviation of all observations from the mean. Well, people typically don't want to know what the average squared deviation is from the mean. People would like to know, well, what is the average deviation from the mean in absolute terms? And because this is a little bit more intuitive than thinking of the average squared deviation, in order to get from the variance to the standard deviation, we square the variance. So the standard deviation is probably the most intuitive measure of dispersion, because the standard deviation can then be interpreted as the average deviation of all observations from the mean. So, but at this point, what is important is, why do we divide by n minus 1? Okay, so of course we could also, and a lot of people think that might be intuitive, we could also, the question is, why do we square in the first place? Well, if you look at it, if you try to just calculate the average deviation from the mean, and if you set, you know what, the standard deviation, sigma, if that is simply all the squared deviations I mean, all not the square, just the sum of all the deviations from the mean divided by n, well, that doesn't work because, as we know from the mean, the sum of all the deviations from the mean, that will always be equal to 0. So we need to get rid of the fact that the sum of all the deviations from the mean is 0. So that is why we square it. In order to get to the variance, we square this term in order to avoid that this gets 0. So now you may say, you know, why don't we calculate the why don't we, that's supposed to be the sigma, why don't we calculate the standard deviation then simply as the absolute difference where we put that, the absolute, so that negative is positive and divide by n. We could actually do that, but when you do that, and that is a little bit beyond this course, it can be shown that this formula does not have as nice characteristics as this formula. So, but theoretically that would solve the problem that the sum of all the deviations from the mean is 0. But we don't do that, so just forget about it. Because if you did it, yeah, it's probably, you know, gives you a good idea of the average standard deviation or the average deviation of the mean, but it has other characteristics that are not as nice as we do the formula n and n minus 1. Okay, so the most important thing is that you for now know the formula. So let's apply it. So let's apply these formulas using this data here. Okay, so the population standard deviation, we said the formula is the square root of the variance, and the variance is summing up all the squared deviations from the mean, square it, and divide by n, and then we take the square root. That's not supposed to be an error. Okay. And the population standard deviation is the sum and we will write it as x bar because that will indicate that we are actually dealing with a sample. And then we divide by n minus 1. And we take the square root. So what's inside under the square root, that's the variance. Okay, so let's just do that. And here I just wrote x bar. What matters is here the formula. It could be alternatively b, it should be mu if we assume a population. But anyhow, let's work with those two formulas now. So this one is what we call the population standard deviation. This is what we call the sample standard deviation. There's a typo. That's the sample standard deviation. So, okay. So now let's calculate first the mean. So we have 8 observations, 2, 6, 11, 18, 26, 34, 44, 56. So 56 divided by 8, the mean is 7. What is the sum? Well, that was 56. So now what is the population variance? So we have to subtract the mean from everything. So we subtract from each observation the mean of 7, 2, minus 7, negative 5, 4 minus 7, negative 3, 5 minus 7, negative 2, 7 minus 7, 0, 8 minus 7, positive 1, 8 minus 7, positive 1, 10 minus 7, positive 3, 12 minus 7, positive 5. And again, those deviations from the mean sum up to 0. Let's double check. Negative 5, negative 8, negative 10, negative 10, 9, 8, 5, negative 5, plus 5, 0. So this sum will be 0, and that's why we have to square it. Okay, so let's square everything. Negative 5 squared. 25, 9, 4, 0 squared, 0, 1, 1, 9, 25. Okay, what's the sum? 25, 50, 59, 63, 64, 65, and 74. Let's double check again. 5, 14, 18, 19, 20, 29, 34, keep 3, 5, 7, 74. So that's correct. So now here in each numerator we have now 74, and now once we have to divide by 8, take the square root, and here we divide by 7. Okay, so now I need a calculator. So the population variance, or if you use the formula for the population variance, so that is the square root of 74 over 8. So we get 3.041, 041. And if we divide by 7, we get 3.251. Okay, so this is just for the mechanics, so that you know how to calculate it. The elephant in the room is of course still the question, why do we divide once by n minus 1 and once by n? We typically divide by n minus 1, and the reason for that is that this makes it an unbiased estimator. So in the next video I want to explain that important concept of unbiasedness of an estimator and what that means. That's a very important concept, unbiasedness of an estimator. And that is what we will do in the next video.